100. I thought subs would just like know to plug in, but those subs they don't. Anything from, it's mostly February. Anything from Chuck the 6. All right, so, oh shucks, I left the answer up here for number 1. When you read page 685, which is the start of 7.4, it tells you what a simplified rational expression is. Now, we've been graphing rational expressions since last Wednesday, so I guess we looked at graphing Wednesday, Thursday, Friday, Monday. You had some time yesterday on your own. I wasn't here. And now we're moving away from graphing into simplifying. So there's 4 class periods of graphing while I was here. So when is a rational expression considered simplified? It's simplified when there are no common factors in the numerator or denominator. I should just go ahead and add. Other than 1, of course, 1's always a common factor. But all right, so you guys have been reducing fractions for years. You might not even remember it comes so naturally to you. This does reduce. Now, 51 and 34, they don't look special to me. 51's not on any multiplication table that I ever memorized, so maybe I grab a calculator. What does 51 divide by? No, but you're right about something about 7. Why'd you go with 7 first? Okay, there is something to do with 7, so that was really good, quick guess.
17.
Yeah, 17. All right, so 51 is actually the same as 17 times 3. Does 34 divide by 17? What is it? So 34 is 17 times 2. So I've broken these numbers up into factors. These are factors of 51, and these are factors of 34. You can then reduce common factors, and this fraction is the same as 3 over 2. This is the simplified form because the common factors have been reduced. You with that, Ellington? Did you reduce number 2? Take a look. This is a new lesson right here. So now, when it comes to rational expressions, it's the exact same concept. You factor, you write in factors, and then you reduce the factors. So the greatest common factor in the numerator here is 4. So that can be written as 4 times x plus 3. And in the bottom, you're thinking, what multiplies to 9 and adds to 6? X plus 3 times x plus 3. So now I have rewritten this in its factors, and now I can reduce top to bottom. You can't reduce 3 factors. So I'm going to reduce x plus 3 and x plus 3. And all that's left over is 4 over x plus 3. So that's what we're working on in this section. We're working on reducing. It's the exact same concept that you learned in maybe 6th grade, reducing fractions, but now we're reducing polynomials. Any questions on 1, 2, or 3 for bell work today? Reducing. All right. So here are some tips and tricks when it comes to reducing. There are 3 types of problems in this section: reducing, multiplying, and dividing. They really are all the same skill set. I'm going to leave this up here. I'll talk about it real quickly, and then I'll leave this up here. You can do your bell work quiz, and then you can look it over when you're done. But when you reduce, you have to be real careful not to cancel out any terms with a plus or minus in between them. So, like, this is a multiplication problem. If there was a plus sign here, I should look at this one actually. If there was a plus sign here, I could not reduce it. I can only reduce multiplication. You can reduce up and down if the factors are right above each other. Those can cancel, or you can reduce diagonally. But if it's a plus or minus sign in between the terms, do not do it. It's only things that are being multiplied. No. So not neighbors. They have to be up or down or diagonal. So when you multiply, it's very similar. You factor anything that can be factored, and then you reduce up and down and diagonal. And then when you divide, we don't actually divide fractions. We keep, change, flip. So we're going to do some keep, change, flip here. You multiply by the reciprocal, which means you turn any division problem into multiplication by flipping the second fraction. Then finally you reduce up and down or diagonal. So we're doing evens today. And I also want to take questions on yesterday's assignment or Monday's assignment. Like last class we went through domain and range again with those graphs. And number 7 from Monday was pretty tricky, so I went through that with first period. So after your bell work quiz, please let me know what questions you have on the last 2 days assignments. And if you need to turn in on paper yesterday's assignment because you did not do it, I'll take it right now. If you felt like you couldn't pick the right graphs, or you could only do solve the top, solve the bottom, and you struggled with your table, just turn in your work if you did not submit anything online. And that's about it. So I'm going to leave this up here and start your bell work quiz.